So I'm going to talk about AutoSD, what it is, how we can build AutoSD images and why they're built that way, and so on. So just a quick overview of the agenda. I'll go through just a quick introduction of the Automotive SIG, and then AutoSD, which is our CentOS. Some may refer to it as a sub-distro of CentOS for the automotive use case or industry, and then a tool that we have called automotive-image-builder, which is used to build AutoSD images. It actually uses OS build under the hood. And then, if time allows me, I'll do a quick practical demo of doing so. So the Automotive SIG overview. I don't think there's much news here to anyone. Those workflow CentOS train has a few SIGs that could end up doing some merging stuff in CentOS train. That some of the changes end up being real eventually. The main difference that the AutoSD has its own image, so you have a parallel process. Kind of, it still leverages CentOS Stream packages, but you have AutoSD specific images because they are kind of tailored for the automotive industry. More, there are things that don't exist there. We try to contribute as much as possible upstream, but sometimes it doesn't make sense to merge things back to CentOS Stream, and that eventually becomes what we would call a Red Hat in-vehicle operating system. This is more of packaging workflow. I think the important part is would be on this part here, where you basically there are things that lives on the SIG that don't go out of the SIG. So, for example, we have a kernel automotive package which has very specific automotive features, such as real print for real time. There are very specific drivers for very specific automotive hardware, and so on. And as the picture implies, we try to leverage as much as possible from CentOS upstream and just package what we need in the automotive SIG, and the same relationship will be between vehicle S and rail. Sometimes we do patch things in Fedora if they are generic enough, but sometimes we don't. So just a quick overview in case you've never heard of the Automotive SIG in general. So going through AutoSD per se, which stands for Automotive Stream Distribution. As I said, it's a very specific image built in a very specific way for the automotive industry. So it's a very minimal, contains we install packages for upstream, but it just contains enough in the image to run whatever you need to do in the for an automotive use cases, application, and so on. It has native OS3 support, so you are able to build a CentOS image with OS3 enabled as well if you want to. You are not obligated to, but you can do it. Also, it has some things called, some may refer to MCO, which it refers to mixed critical orchestration. That's named for how we orchestrate containers inside the AutoSD. So in the automotive industry, some applications they have to be compliant to some ISO certification, and so on. So we provide a way for users to orchestrate those applications in containers. They are we don't run Microshift or K3S. You basically orchestrate everything in systemd through quadlet or container files, which I'll get in a few minutes. We also have a protocol, BlueChi, related to Eclipse, which allows you. It's basically a systemd controller that allows you to manage its units from different nodes from a main node. So we're able to create cross-node dependency in systemd. And QM is something that provides an isolated environment to run those applications that they can't interfere with the whole operating system. So this is what we call a quadlet file. It's basically a unit file with some extra container section, with basically just by Podman later. So Quadman is shipped within Podman. So if you install Podman with DNF, you get Quadlet for free. Basically, when you boot your operating system, Quadlet will parse this file and generate a system unit file. Or if you reload your system daemon, it will also reparse that file and generate a system unit file, which will actually be used by systemd. So yeah, it's a bit small, but that's basically it generates a file. This is the generated file from the previous slide that's used by systemd to run a containerized workload. So basically, all parameters under this container section will basically will be used in this this exact part here section. They're all become Podman parameters. So there's way more. You can use way more things there. That file is basically a very minimal example. So Automotive Image Builder, AIB for short. It's a CLI maintained by the Automotive SIG. You basically create what we call AIB YAML file, and it also and then you basically what the tool does basically is translate that YAML file into an OS build JSON file. And then you can use OS build to actually build automotive image. So it's basically using OS build and Leonardo to actually create and assemble an image. It also has if you're not familiar with QEMU, it has a runner command, so you can just use this runner subcommand to run a QCal file with QEMU. It has some issues with running inside containers. You still can do it, but you need to run in unprivileged mode. But that's more on OS build than the automotive image builder CLI per se. And it also it natively supports. You can build a distro, an image with targeting distros for AutoSD, CentOS Stream 9, or Fedora, or you can add your own distros. In this case, are basically there's a collection of it just refers to the repositories, a bunch of RPMs that you are installing from. So you could use any other distros that have RPM support, basically. This is what AIB manifest a very minimal one looks like. You can see it's a very straightforward definition. You have a content section that basically define the content of your image. So repositories, container files, packages. You can copy files from the file system as well. You can also copy files from the URL if you want to. So in the particular case, the source path becomes a URL rather than a local path from your host machine. It's important to note that the source path is always related to the AIB manifest file directory. So to just things that what I'm sharing here, there's a bunch of things here. The last link to my demo, and I'm just stop sharing my my browser, and I'll share my terminal to show a build in action. Oh, okay. So since I think I have a bit more time. So here I have this is the file that I just showed. Basically the same thing, nothing new. You can also use a what we call an MPP file, which is basically a not so friendly version of AIB file. It's more similar. This kind of file is almost like OS build JSON file in YAML format. So in case you need further customizations that AIB file does not allow you to, you can write a file like this. You can see that's more cryptic if you're not familiar with OS builds, generally speaking. So I'm going to show how the workflow would work. So first of all, I'm going to run through commands. First one, I'm going to run automotive-image-builder compose. That process basically, as I said, transforms that YAML file into a SBuild JSON file. So I'll just copy that command here. This command usually doesn't take that long. So it basically generates this SBuild JSON file in here. This is basically an SBuild JSON file, and it contains everything that the image should contain. So you can use so that container section becomes this scopil section for SBuild that basically is going to pull that image locally and so on. Once you have it, you need to run this SBuild command here. As I said, it doesn't work usually doesn't work. Since I'm using Silverblue inside a toolbox, so it won't work. So I'm just running it on my host machine. This process for these images took maybe 1 or 2 minutes. I'm just going to show. I have already built the image before the demo, and so I'm going just to run. I'm going to use the automotive, as I said, the runner subcommand basically it will invoke to do under the hood while my image is still being built. So in here, I'm just going to log in as root as password. You can see here that radio container file. It's in here. So as I said, when you boot the OS, Quadlet parses this file. The generated file is usually located in run, systemd, and generator. You can see there's a radio service right here as well. And if you check the content of that file, you see there's the whole generator. This is the file used by systemd to actually run the service. So if it does the status, so it basically invokes a podman command in this case. Radio, then you can see the output of the service. There is running purple and so on. Because it's using podman, you can also run a podman PS, and you see the containers running properly. And also, the OS release file should reflect that you are using Automotive Stream Distribution and so on. The image build is almost done. Once you reach that stage, is basically just writing the QCal file in this case. So it basically creates a temporary file system. It writes everything there, and then once the build is done, it writes its content to actual file to be used. Either a raw disk or a QCal image, or also build support very different formats that you can use. That will be the quickest demo of my life, I think. Any questions?
So when are you going to make model cars run on this?
Soon enough, I think. Hopefully.
I'd like to see something like demonstrable. It would be very cool to see something demonstrable that people can play with AutoSD, because I know that the challenge with this stuff is the real world usage of this is highly regulated and super difficult to discuss and show. But right. it like on some level, I feel like I don't know what's going on or what's happening or how the progress is going or how to show it off or any of these other things. Because there's nothing, I mean, this is attached to something physical, but there's nothing physical to show when we're talking about it from a CentOS and a contributor point of view. And I know early on there was some talk about doing stuff with Raspberry Pis and plugging it up to model trains and stuff, but like nothing seems to have materialized. Is there something going on or? whatever to make something more real out of this?
Well, I mean, we have a few boards that test this stuff, but it's just a board, no different from a Raspberry Pi, in a sense. We are currently working on running this project here inside AutoSD. This is a fully open source ADAS. ADAS stands for autonomous driving software. So it's basically something that allows your car to self-drive. We're in the process of running that. We already have actually. We have an image that runs that stack. You can see here. So basically, that program allows you to run a 3D simulation. It kind of emulates how the car would run in a real environment scenario, or an emulated scenario at least. I've been trying to look some ways to make make a small board with wheels and run it. But yeah, that running AutoAir and 3D simulation might be the closest. That's more than just terminal output than we have today. I also know about this company lately. Like they have developed real physical developer kits for cars. I think they are a bit big, but it sounds an interesting thing to look at in the near future.